Welcome to True Projects. In this video, we are going to explain about the project that is a web-based interface that leverages machine learning to assess an individual's vulnerability to brain stroke. So before getting into the execution, first let us understand what is this project about. A stroke, which is also called as cerebrovascular accident that happens when the blood flow to the brain is interrupted. This can occur either because a blood vessel gets blocked, which is called as an ischemic stroke, or because a blood vessel bursts, which is called as hemorrhagic stroke. When the brain doesn't get enough blood, it can get damaged, which may lead to serious problems. And strokes are the major health concerns worldwide. They are one of the leading causes of death and long term disability, affecting millions of people every year. Catching a stroke early is extremely important because timely medical care can save lives and prevent severe complications. Sometimes people may experience temporary warning signs called transient ischemic attacks, that is TIAs, which are brief episodes showing that a stroke might happen soon. Recognizing these early signs can help in taking preventive measures before a major stroke occurs. So, even though machine learning models and deep learning models have made it possible to predict the risk of stroke, there are still some big challenges. One of the major problems is that in the most stroke data sets, there are very few positive cases, meaning only a small number of people actually had a stroke. This makes it hard for models to accurately identify people who are truly at the high risk. And here, another major issue is that most existing prediction models, that is, prediction tools, are either designed for research or built into complicated clinical software. So, regular people or healthcare workers without technical training can't easily use them. On top of that, many of these models are like black boxes, which means they give a prediction without explaining why a person is considered to be at high risk. So, because of these problems, there is a real need for stroke prediction methods that are easy to understand, accessible to non experts, and reliable so that high risk individuals can be identified early and properly, that is, proper preventive measures can be taken. So, to overcome with all such issues, the proposed system is a computer based tool that uses a machine learning to predict a person's risk of having a stroke. So it looks at various health and lifestyle factors like age, gender, body mass index, blood pressure, and habits such as smoking or exercise to understand who might be at higher risk. So, what makes the system helpful is that it can detect even small patterns in the data that might indicate a higher chance of stroke. At the same time, it is designed so that doctors and healthcare providers can see which factors are contributing most to the prediction rather than just giving a number without explanation. This makes the prediction not only accurate but also easy to understand and useful for making decisions about preventive care. And here, one important strength of the system is that it can handle a common problem in healthcare data, that is, there are usually far fewer stroke cases compared to the non stroke cases. This makes it tricky for models to correctly identify people at risk. So the system solves this by using technique called SMOTE, which is synthetic minority oversampling technique. It creates synthetic samples of the minority group, that is stroke cases, and combines this with the strong machine learning models that are logistic regression and etc. This approach helps the system to catch more high risk individuals without losing accuracy overall. So in addition, here in this project, it incorporates explainable AI techniques which show how different factors contributed to the prediction. This means doctors can and the users can understand why the model thinks someone is at high risk of the stroke rather than just seeing a number. Moving on, to further improve the performance of this project, here an extension model has been incorporated, which is an ensemble model. So instead of relying on just one model, this approach looks at the predictions of multiple models and combines them to make a more accurate and reliable final prediction. And here we have also developed a simple web interface by using Flask framework with the user authentication so that users can securely log in, test the system, and access their results in a personalized and safe way. This makes tool more user friendly and secure. And coming to the implementation, to implement this project, here we have followed the steps which are mentioned in the flow of work. So let's understand how we have implemented this project. First, we have imported all the necessary Python libraries and packages. These are needed for tasks like cleaning the data, visualizing it, building the models, and evaluating their performance. Then comes exploring the data. So here in this step, the stroke prediction dataset is loaded and analyzed to understand its structure, features, and the target variable, that is stroke and non-stroke. Then comes data pre-processing. Here any missing values in the dataset are handled by either removing or filling them. Duplicate records are removed to ensure the data is clean and reliable. Then comes the step data visualization. So here the distribution of the stroke versus non-stroke cases is visualized. A correlation matrix is generated to see how different features relate to each other. Then comes scaling the data. So the dataset is normalized using different scaling techniques like min-max, standard, and robust scalars to make the features comparable. And then comes oversampling. So here, since there are far fewer stroke cases than the non-stroke cases, oversampling methods like ADA, SYN, random oversampling, and SMOD are used to balance the dataset. Then comes model training. Here, various machine learning and deep learning models are trained on the prepared dataset to predict the strokes. And we have evaluated all the models using accuracy, precision, recall, and AUC score. And we will be saving the best performing model for the future use. Then comes explainable AI techniques. So here, techniques like CLIMB and SHARP are applied to explain how each feature contributes to the model predictions, providing transparency. Coming to the front end, here we have developed a simple web interface by using Flask framework, including registration and login features supported by SQLite database. And in the front end, users will be able to provide the input as feature values that will be pre-processed at the backend. It will be fed to the train model, and the train model will be giving us a prediction. So this is how we have implemented. Now coming to the algorithms used. These are the machine learning algorithms that we have used in this project. And here we have the deep learning models. And here we have voting classifier model. So each model is trained on the Eats mode technique. Moving on to the requirements. To implement this project, basically we need hardware and software requirements. In hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute it. To execute, open the code folder that contains source code files. So let's open it. These are the source code files of this project. And in this folder, we have the algorithm information, which will be loaded into the project code during runtime of the application. In static folder, we have files related to CSS, JavaScript, and Bootstrap files, which are important for the project's visual appeal. And here we have templates folder. In this folder, we have HTML pages that are used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here in this folder, we have test cases that we will be using in the front end. This is the app.py file. So this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have the dataset that is used in this project. Let's open it. It's opening, just wait for a while. And here we have the dataset. So this is the dataset. And these are the parameters based on which we will be predicting whether the person has stroke or not. So we will be using this data to train the models. Now close this. And this is the notebook file, which is a Jupyter notebook file. It contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. This is the database file, which is used to store the user information. And this is the stroke prediction dataset. Now let's execute it. To execute, copy the path of the code folder from the address bar of the file explorer. So copy it. Now open Anaconda prompt. So it is open. Now give the command cd, give the space, paste the copied path and click on enter. Here if you observe, current directory is changed to the code folder's path. Now compile app.py file. So give the command python space app.py and click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is the localhost and the port. So this is the localhost and this 5000 is the port. Now copy this local link provided by the Flash framework and paste it in any web browser. I'm copying the link and I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flash framework. So we need to get started first. So click on get started and provide all your details to create an account first. So I have already created my account. I will directly sign in. Click on sign in, give username and the password to log in. And now click on sign in. We have signed in successfully and redirected to this prediction page of this project. So this is the prediction page of the project. And here you can see parameters, right? These are the parameters need to be given for predicting whether the person have stroke risk or not. And let's understand what are these parameters are. So first parameter we have is the gender. So gender indicates whether the person is male or female, and gender can influence stroke risk due to biological and hormonal differences. And here we have age. It is a person's age in years. Stroke risk generally increases with the age. And here we have hypertension status. So it is whether the person has high blood pressure. Hy- Hypertension is a major risk factor for the stroke. And here we have heart disease status. It indicates if the person has any heart related diseases, and heart problems can increase the likelihood of the stroke. And here we have marital status. It is whether the person is married or single. Some studies suggest that social support can impact overall health, including stroke risk. And here we have residence type. So it is the urban or rural residence, lifestyle, and access to healthcare in different areas may influence stroke risk. Here we have average glucose level. It is the presence of blood sugar level. That is, it is the person's blood sugar level. So high glucose levels or diabetes increase the stroke risk. Then we have body mass index. It is calculated from height and weight. Obesity or underweight conditions can influence the stroke risk. And here we have employment details, that is never worked, private worked, self-employed, and also children. So this never worked indicates the person has been never employed, and this private work indicates employment in the private sector. So the self-employment indicates if the person work for themselves, and the children indicates dependent or child status. And here we have formerly smoked. So this indicates the person used to smoke, and here never smoked. It indicates the person has never smoked and currently smokes. It indicates active smoking. So smoking is a well-known factor for risk. So these are all the parameters. So here these parameters are by default no. So we can change to yes if the person has that option. So let's start entering them. For that, let's open the test cases. So open test cases folder. Let's open this file, which is a sample file. So these are the parameters that will be giving us input now. So here class 0 is one type of class and 1 is another type of class. So let's check with this case. So let's select the gender as male. Age is 67 years. Hypertension is yes. Person has hypertension. Heart disease status is yes. Actually, this hypertension is no. Heart disease status is yes. And marital status is married. Residence type is urban. Glucose level is 228.9. It is 228.9. Body mass index is 36.6. Work type never worked is no. And then here we have work type private, it is yes. Self-employed is no. So here we have self-employed, it is no by default. And here we have work type children, it is no. Formerly smoked, it is yes. And never smoked, it is no. And the last one we have is smoking status. So here it is also no. Now let's click on, that is now let's click on analyze stroke risk. Click on it. So this given input, it will be pre-processed at the backend. It will be fed to the train model. Then the train model will be giving us a prediction. So just wait for a while. And here we got the prediction that risk level is low. So here you can see risk level is low, and this is the AI confidence that is giving 87.6%. And this is the assessment summary we got from the model. And here are the recommendations. Let's do with the new assessment. So click on it. So let's enter the parameters. And now let's check with this case where gender is female, age is 49 years, hypertension is no, heart disease status is no, marital status is married, urban 171.23, the body mass index is 34.4, never worked is no, work type private is yes, self-employed is no, work type children is no, formerly smoked is no, smoking status is no, and currently smokes is yes. Now click on Analyze Stroke Risk. And here we have the AI confidence that is 100% in predicting low risk. And here we have assessment summary recommendations. Let's try with the new assessment. So click on New Assessment and let's check with this case where gender is male. So let's give as gender as male and age is 81 years. Hypertension status it is no. Heart disease is no. Married it is. Status is married. And then residence type is urban. Average glucose levels are 186.21. Body mass index is 29. Never worked it is no. Private work it is yes. Self-employed is no. And all other parameters are no. Except smoking status, that is smoking status formerly smoked. So give it yes. Click on Analyze Stroke Risk. So here you can see prediction to be high risk. So the person has high risk level for getting the stroke. And here we have AI confidence that is 92.5%. And here we have assessment summary. Here we have recommendations which are to be taken. Let's check with the last case. So click on new assessment. Now let's check with this case. So here gender is female, age is 59 years, hypertension is no, heart disease it is no, marital status is married, rural, one that is 76.15. Body mass index is 30.361. So body mass index is 30.361 and never worked is no. Private worked it is yes and the other two are no. And smoking status, all other are no. Now click on Analyze the Stroke Risk. So here you can see there is high risk for person getting stroke with these parameters. And here we have AI confidence of 80.4% and here we have assessment summary recommendations. Now let's check with the view analytics because we're done with the prediction. So click on it. And here we got the graphs. So this is the distribution of body mass index after random forest imputation. So click on it. Here on x-axis we have body mass index and on y-axis we have count. It shows the body mass index distribution. Now close it. And here we have stroke sample outcome graph before balancing technique. So here if you observe, blue color represents not stroke and orange represents stroke. 95% of the data set is of not stroke and only 4.9% is with the stroke. So here you can observe class imbalance. So if we train the models with this data itself, model will get the high accuracy only for predicting this not stroke. It will not predict the classes of this stroke. So that is why we have done sampling technique, that is we have used sampling technique to balance this data set. So after balancing the data set, here you can see each class is represented, that is each classes has equal percentage of the data. Now close it. And here we have model confusion matrix. So this is the confusion matrix and here we have accuracy comparison graph where on x-axis we have all the models that we have trained and on y-axis we have accuracy. And here we have recall score. Sorry, this is the precision score. And here we have recall score. This is the recall score. And here we have FN score. This is the FN score. And this is RSC AUC score. And here we have SHAP explainable graph. So here, this color represents, values with this pink color represents the high feature importance, and with blue color represents low importance. Close it. Now click on sign out. So in this page, just by giving required inputs to the application will be accurately predicting whether the person have low risk of stroke or high risk of stroke. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.